This is Euclid Book 3, proposition number 13, part 1. We have drawn two circles here. This one's A, B, D, and we have another circle up here which we're going to cover in part 2, and we're going to label it in part 2. Then we have drawn another, what is supposed to be a circle but ends up being an ellipse, and it starts at E, goes down to B, and goes down to D. Now, we're going to first of all establish that ABD has a center point of G. This is the real center of circle ABD. But we're going to say hypothetically that this point is the center of ABD. We know it's not, but we're going to say hypothetically that it is. And then we're going to say that point H here is the hypothetical center of supposed circle EBD. Now, EBD is a very ugly ellipse, but we're going to say hypothetically that it is a circle. Okay? Now, we're going to join points G and H together, and they're going to fall on line BD. And this is by Euclid Book 3, proposition number 2. And then we can say that the length of BG and GD are equal in size because already I have a circle are equal. Now we can also say that BG is greater in size than HD. Okay? And we can say this because of this. If BG and GD are equal in size and HD is a part of GD, then we can say that BG is greater in size than HD because GD is also greater in size than HD. Okay? Hopefully you followed all that. Alright. Then we can go on to say that line BH is greater in size than HD because BG plus GH would obviously be greater in size than HD. Alright. Now, if we were to say that H was the center of EBD, then we can say that HD and BH are equal in size. But we just already said that BH was greater in size than HD. Now, BH can't be greater in size than HD and also equal in size to HD. That's impossible. So, what we were trying to prove the entire time was that if a circle must not touch. A circle cannot touch another circle at more points than one. Okay. No circle drawn inside or outside another circle can touch at more than 1 point, and that's what we were trying to prove. And if it touches at 2 points, then things become impossible, which does not happen. So, if you draw a circle, whether it be internally or externally, it's only going to touch at 1 point. And that's what Euclid was trying to prove. I will tell you the rest of this in the next lesson. Stay tuned.